Hello, my name is David James, and I'm joined with my colleague, Mike Beavers. We're both members of Esri Smart Airports GIS team. Thank you for scheduling time to meet with us. In the next 30 to 45 minutes, we're going to showcase Esri's Smart Airports GIS Foundation and the value it will deliver to your airport. Our presentation topics will include an overview of the foundation, a demo, solution review, and getting started and next steps. The Smart Airports GIS Foundation has been designed to realize three valuable business advantages. Number one is alignment with FAA GIS requirements. Number two, improve airport planning and operations. And finally, enhance safety management. As the FAA introduces the next generation of air traffic control systems, Airports GIS will become mission critical for all airports. The FAA plans to implement most of the next-gen traffic control system by 2025. That leaves airports just a few years to implement really accurate, standards-based GIS systems. The Airport GIS Foundation will drive new levels of performance across all aspects of airport planning operations. The list in this slide highlights some of the ways that you will be able to leverage new GIS capabilities. The Smart Airport GIS Foundation will provide a framework to support your airport's safety management program. All safety initiatives rely on a common understanding of location. The Airport's GIS Foundation will establish an authoritative common operational picture for all safety-related initiatives and incidents. Okay, let's take a break from the slides and let Mike demonstrate the Airport GIS Foundation for you.
Thank you, David. What I'd like to show you now are some desktop tools that allow you to align your GIS with the FAA GIS requirements. There's tools that enable the user to bring in data from a variety of different formats and integrate them into one standardized schema, as you can see here. So the data includes a variety of data checks and the ability then to validate whether or not that data is compliant. And when I say that, I mean making sure that the data is both geographically accurate, true and correct, and that also the attribution complies with the Part 18B. So there's data checks that I run through a data reviewer, which then quickly give me the ability to analyze and identify errors, whether they're attribution errors or topological errors. And in this case, you can see that one of the validation checks, of which there are hundreds, that there's some missing information that's critical. In this case, you'll see it's the runway designator that's missing. So when you run these tools and validate your data against them, you can quickly identify and fix these errors so that when you submit that data to the FAA, it is approved. What we'll show you next is a viewer that consumes the data that you have run through the 18B data checks as part of your airport's extension. So this standardized web browser allows me to see things like runway lights. You'll see in this web viewer that I could identify lights based on category or type and quickly see the summary of the total number of lights across the airfield. It also comes with a variety of base layers, including high-resolution imagery. So you'll see as I zoom into the viewer, we have a very accurate and up-to-date base layer that is included with your subscription. As I then zoom in, I can perform some very simple analysis. And one of the most common is, if I'm located here, what assets and infrastructure are nearby me. So if a contractor were to use this app, they could go in and say, I'm going to begin doing some work here and I need to tie into some survey control. So how quickly I could find that using these would be just with a matter of a click on the map, identify the survey control that I want, look at the coordinates in the attribute table, and then even be able to share the directions with someone who needs to go out and then begin work or construction at the airport on a new project. Simply by clicking on a feature in the map, I could pull up a pop-up and it would show me detailed information about that specific feature, in this case a runway light. Another very important component of the airport's extension is the ability to generate approach surfaces and do analysis of those surfaces to verify if terrain or obstacles at a specific runway at an airport is free from any violations. Let's zoom in here at the Knoxville Downtown Airport, and I've generated this approach surface, and I'm evaluating whether or not a standard approach would be authorized or approved. And in this case, you can see that terrain and these obstacles are poking into this approach surface. So with data that you have that you maintain internally, or data that's offered through the FAA or through a vendor, you could then bring that data into your standard viewer and do analysis like you see here, where these light poles actually extend well into the approach surface, in this case by about 37.5 meters. So it's critical to understand that with your data in place and accurate, then you can generate these Part 77 surfaces and other types. So with runway centerline information and obstacle information, as well as terrain information, then I can generate approach surfaces like I've done here at the Burbank Airport. And it's obvious that the terrain extends well into this Part 77 surface. In fact, there are no instrument approaches flying in from the east to the west at Burbank. Although if I'm making a standard approach flying from the west to the east, you can see this aircraft is following this approach surface down to the runway. Now in the event that aircraft has to go missed approach and loses an engine, the airport needs to guarantee that that aircraft is going to be free from obstacles or terrain during its climb. A vendor captured rooftop information from LiDAR, and we brought that data into this viewer and did analysis on it. Wanted to see if any of the rooftops actually extended into an existing approach surface. So you can see the data associated with those rooftops. And also you'll see now these data that are those rooftops, there are a few of them that actually extend into and violate that surface. In this case, not much, by about 4.6 meters. So the extension allows you to do that sort of analysis quickly. At the San Diego International Airport, likewise, this aircraft is making an approach, and the approach path had to be modified from a standard approach so that it could be clear from terrain and obstacles. As the aircraft taxis off the runway, it follows standard signage to get safely to its gate. Using the airport's extension, you can render your sign plan in 2 and in 3D and visualize that with a standardized viewer, which allows anybody at the airport who's doing updates or validating their signage plan to be able to quickly, on a mobile device out in the field, view that data, that sign plan, as it appears in real life. And those are driven by the data itself. So when I select that sign, you'll see the rules that render that sign as part of your sign plan. So what you can do then is, for both sides of the front and the back of the sign, be able to quickly in the field validate your sign plan so that when you submit it or update it with the FAA, it's approved. ArcGIS allows you to integrate building information models and read those directly inside a web browser, which makes seeing a complex model like this very fast and easy. In this case, what I'm going to do is validate whether or not, say, this aircraft could fit at a specific gate, which is a very common need at airports. So I could easily take the measure tool and measure the wingspan of this aircraft to confirm whether or not it would fit at this specific gate. So these web browsers, again, are secure, easy to use, and require no special software. You can take your GIS into the field using any mobile device. I'm going to do an airfield inspection using this configurable off-the-shelf solution that I've created. I'm going to conduct my airfield inspection, and in this case I discover FOD on the runway, and I can report that quickly and easily using this form. I identify the location of the FOD, select its urgency, take a picture, sign it, and then right away it shows up in a dashboard that I've configured. It's data-driven, meaning the data about that inspection and all the others appear here. You can see that individual inspection and detailed information about it, including a photograph, directly in this browser-based tool. Thank you, David. Back to you now.
Okay, I'd like to reinforce some of the key capabilities. The Airport GIS Foundation is designed to ensure efficient, high-quality data management as required by the FAA GIS requirements. The Airport's GIS Foundation provides you with automated tools and routines that will ensure the highest level of data quality. The Airport's GIS Foundation will also streamline the airport layout plan process, enabling you to support accurate ALP data for FAA when required. Like all airports, you're probably reviewing more and more potential vertical obstruction cases. The Airport GIS Foundation provides you with the tools required to assess obstructions quickly and accurately, ensuring the safe operation of your airport at all times. The Airport GIS Foundation allows you to easily share high-definition imagery with all stakeholders throughout the airport using standard web browsers. This will help everyone to have a common understanding of the potential impact of obstructions. The Airport GIS Foundation will enable you to develop detailed airfield signage plans as required by the FAA. The Smart Airport GIS Foundation will enable you to take advantage of many of Esri's web, mobile, and easy-to-configure data-driven dashboards. In conclusion, we know from experience of working with many world-class airports that the Esri Airports GIS Foundation will realize these important business benefits. What I'd like to do now is talk about some next steps and get started. We've prepared this draft proposal for your consideration. We'll be happy to discuss this further with you at the end of the presentation.